In this video, I will discuss differential analysis, where we test differences between variables. First, let's start with a t-test. We use a t-test to check whether there is a significant difference between two groups. For example, in our case, we can use to test if there is a difference in customer spending between customers who are exposed to the promotion and those who are not exposed to promotion. So this code that you see perform a t-test to compare the average spending between two groups of customers. Spending is the variable of interest we want to compare, and the promo exp is the grouping variable. So here we have two groups. One is for those who are exposed to promotion. The zero is for those who are not exposed to promotion. And we have here the data brew time tells R to use the brew time dataset. So when we run this command, our tests whether mean spending differs significantly between the two groups. So let's run. We have to select the code and then we click run. So this is the result, and as you can see here, the output displays several values. The p value is the most important. So if it is less than 0.5, it means there is statistically a significant difference in spending between customers who are exposed to promotion and those who are not. So in this case, the p value is less than 0.05. It means there is a statistical difference in customer spending between those exposed to promotion and those who are not. You also see the mean of each group here. Here, a customer who exposed to promotion spend on average 81.5, while those who are not exposed spend 64.12. So this showed that on average, customers who saw the promotion spend more, confirming the effect of promotional exposure on spending. So based on this p-value, we can conclude that promotional exposure to customers is really matters in customer spending. Now let's move to the second differential analysis, which is ANOVA. We use ANOVA when we want to compare more than two groups. So let us compare whether customer satisfaction is different among the four loyalty groups in the dataset. So in the dataset, there are four loyalty groups: bronze, silver, gold, and platinum. So first, let's see the average satisfaction for each loyalty group. So this command tells R to calculate the mean satisfaction for each loyalty group. So you can see the average satisfaction for each loyalty group. So this aggregate function in R calculates average values for groups. So the average for bronze is 2.0, for gold 2.3, for platinum 2.6, for silver 2.2. So now we want to see whether this upgrade satisfaction is different between quality groups. So next we use ANOVA test to check whether these differences are statistically significant. Let's test the difference. This command you see is used to do ANOVA, where we are testing whether customer satisfaction differs across the loyalty groups using the real-time dataset. So in this command we have AOV. It's a function in R that performs the ANOVA test. This part means satisfaction to loyalty. It's testing whether the average satisfaction, which is our variable of interests, differ across different loyalty groups. This tilde means explained by. This means satisfaction explained by loyalty. And we have data real time, which tells R which data set to use for the analysis. We then have to assign the result to a new object or a new variable called ANOVA model, which stores the ANOVA results in memory. And we have this summary command which displays the full ANOVA table in the console. So let's first run ANOVA model and then the summary to see the ANOVA result. Here we go. As you can see here, this is the p-value, which is less than 0.05. This means the result is highly significant. That means the probability that these differences occurred by chance is extremely small. Therefore, we can conclude that the mean satisfaction across the loyalty group is not equal. This means customer satisfactions differ significantly among the loyalty groups.